So my name is Jakub Oboza, and can you hear me? Yeah. Cool. So this will be the story that we had while we were building an SMS gateway, which obviously is a messaging system to deliver messages between the people. So what I'm going to talk is everything. What we the problems that we had, the language, scalability issues, fault tolerance, how it impacted our choices, and what did we choose. And actually, the most fun is at the end, where I'm going to be talking about the operational costs and operational, maybe not costs, but stuff that you have to be aware and you're not always aware about. So yeah, the project is an SMS gateway. I'm working for a company in London, and I think that's one of the biggest gateways that are out there. So basically, what is an SMS gateway? But before I'm going to talk about SMS gateway, we need to be like a telecommunication specialist. Yeah. So first of all, we have 3 terms that we need to learn. MT is mobile terminated. That's the message that is delivered to a handset for a person. And then we have MO. That's the message that is sent from a handset to your the operator or to a different person. And we have DR, which is a delivery report, which is generated by the operator to the client, or by the gateway to the client that the message was delivered or the message was received. So basically the project started in 2009, and we have to be aware that all the decisions were done in the context of 2009. It was not 2014, not 2013. Requirements for the project it was a time-constrained project. Initially we had 9 months, but later on it was reduced to 6 because the competition actually got the message that the company is working on SMS gateway, and they were not happy about it. And it was not really a startup environment because the company was already established. They knew what they want, and they had to build it. So what is the SMS gateway like in this context? Basically, it's delivering APIs because operators work in a certain way. And by operators, I mean, for example, like Orange or T-Mobile. They work in a certain way. So, for example, they're not going to be like dealing with you if you send less than 2 million messages per month or something ridiculous like this. So even big stations like, I don't know, BBC, Channel 4, ITV, they are not sending this kind of volumes, or not every month. Usually it's something close to this, but they cannot guarantee 2 million SMSs for like every single operator. And SMS gateways basically say, yeah, we can do it. We're going to handle the traffic, and we're going to handle the operators, and you are our client, so why not? First decision that was made was programming language, and that actually was hard and easy decision because the initial requirement was it needs to be fault tolerant, and at that time, when you're going to think about languages, it's not really going to be hard to choose, to decide what was the final decision. But initially, team had the experience in Ruby, so they know how to build stuff in Ruby. They previously built stuff in Ruby, so, that definitely was not the right choice, because even if the gateway would be built in Ruby, where there was some attempts to build the gateway in pair and quite successful, they were not able to handle the volume of traffic. So we had the second team that was working with Java, and they were building a different product. So there was not really anything that could be an incentive to move them to this project because they were occupied. And as we know, actually getting developers is not so easy task. So Scala and Go were actually kind of out of scope because at 2009 nobody had tons of experience with it. Haskell was there, and everyone considers always Haskell, but we did not have stuff like ASON, MySQL Simple, or even Cloud Haskell, which even today, if you would think about Cloud Haskell, you would be not super sure if it's the right choice for your for your business application. And there was Erlang, yeah, 20 years of experience in telecommunication, like relationships, ready libraries, fault tolerance, almost out of the box. So the decision was really simple. Yeah, we're going to go with Erlang because it's awesome. The second thing that we had to think about was database. And there was two really big things. So the business knew that we cannot lose any MO or MT. That's like a message. So basically we cannot lose anything. And we have to be consistent, which is a kind of a lie. You can lose some stuff, but you should not. Everyone is unhappy when you lose stuff. So at that point, we thought, okay, first thing, MySQL. But MySQL is kind of like a thing that if it's going to go wrong, then you have a problem because your master is down, you have to manually restart it, you have to have a failover to slave. It's tedious, yeah? And there is React. React was actually, out of the box, the solution that we were dreaming about. So it seemed really good, yeah? It's only version 0.12, but, what can go wrong? So what we did is, let's go with React. And React was kind of like suggested by the consultancy that we had, because what you do when you start to build the gateway, you bring in consultants, obviously. So what is the architecture and the design of this particular thing? So because we were experts in doing stuff in Ruby, and we know that we're going to have a client side, which is a place where clients go and configure their API, and we have the backend, which is the gateway. We thought, okay, you can build one thing in Ruby, and that's going to be fast because it's only like few forms, and the main bulk of the development can go into Erlang and to the gateway. So basically, that's what we did, yeah. And the front-end application is in Rails, and that's actually pretty good. But interesting is the backend. So basically, we have like many nodes, and every consultant that goes into this project says, "Wow, you have like many nodes," because for everything, almost you have like a separate node, or for every like a logical part of the application. Basically, that's the simplest flow that you can have of an MO that is sent to the gateway. So when we have this user John and he texts to he's taking part of the, let's say, ITV competition, and they say like, text us 1 and you're gonna win something. So what we do is, what he does is he texts to the operator 1, the shortcode like 666, and operator sends us SMTP, for example, SMTP request or HTTP request if it's T-Mobile, and we get it on the operator node, and then it's routed. Then the message is acknowledged and routed to router node. Then we do some checks using the counter nodes, because we have a separate node that is checking if this user is actually not spending more than he should. And that's another requirement. If you're working with operators, you have to comply to like dozens amounts of requirements. For example, people cannot spend more than £1,000 a day, yeah, using their mobile. And if you will not comply, operators will be unhappy with you. And if you are an SMS gateway and operators are unhappy, your business is in danger. So what happens now when from router, the message goes to client node, and the client sends the request to the application. Yeah. What's going to happen next is the application that is handling like outside of the gateway, the traffic's going to do some stuff and maybe trigger a request to send an MT to this user. So how do we handle the communication between the nodes? Well, everyone's going to use queues, yeah? That's the simplest solution. And what we did, we used the queues. But the consultant that we had was kind of like against RabbitMQ. I don't know why. So we decided to run with our own queuing system, and the argument was like, the RabbitMQ is not reliable, you can like drop messages, you can have timeouts. You know what happened when we rolled our own queuing system? We had timeouts, drops of messages, everything, yeah. But in the end, we managed to do everything correctly. Operator nodes. So basically, because we want to have a fault-tolerant system, for every single operator, we have at least 3 nodes. And because when you work with the telecommunication operators, they're going to say to you, for example, we will give you only 2 binds. And binds is kind of like a connection to the operators, but there's also something which is called a connection. And basically, they're going to say we can give you only 2 binds. And most of the operators will work with the SMTP or HTTP protocols. And if this happens, you are limited. You actually can have 7 operator nodes, but you're limited to 2 binds. And that limits how you can be, how fault tolerant you can really be in terms of physical boxes going down. We have client nodes. So we have plenty of client nodes, and most of the API is delivered by HTTP. Some of the API is delivered by SMTP, because some of the people want to implement SMTP in their applications. The other types of the nodes that we have are counter nodes and callback nodes. So callback node is the node that is sending the DRs to the clients, delivery reports. Basically, whenever we send the NMT, so the message, so the client schedule in our API to send a message to a particular phone. When the phone receives the message, the operator sends the delivery report to us, and we send the delivery report to the client. That's actually pretty important because we build on successful message, that the message that we successfully delivered. Deployment and distribution. So how we do it is, I know it's going to sound scary, but I'm going to say it. We use Capistrano for deployment, and it worked really well for us. We have many physical boxes, and the problem here is that if you're working with operators with this kind of scenario, you cannot ever have probably continuous deployment because you cannot lose any single message. And that's the really big risk. If you're going to say to anyone, well, we're going to lose like 1 message, they're going to freak out because if somebody, especially premium messages, if somebody's going to lose money, then they just don't want to do it. They're going to go to competition, and competition is going to lie that they're going to deliver all the messages. So the early life of the gateway was brilliant. We deployed it and it was working. Nothing really broke. We had some problems at start, but actually that was a lie. A lot of stuff broke. And first, because initially we thought, okay, we are using like early version of React and the timeouts are okay, but we did not have any notion of throttle queue. So the concurrency was unbound. So React, Erlang's gonna give you the tools to build best concurrent software, but will not save you from doing bad stuff. Yeah. So even if people will say that you can have unlimited number of processes, that's a lie. Every beam has a limit, and if you're going to reach this limit, he's going to start to swap, and you will have problems. So you have to be aware that there are some limits. What we did next was like, in React you have this scenario of vector clocks. Well, we can disable them. It's going to go faster, yeah. So we disabled vector clocks in React, and that actually led to corrupted data. And vector clocks in React works in a way that when you have a data that is possibly corrupted, you need to resolve the conflict on read. So why to resolve the conflict? Well, if we can just use the most recent data in React. Well, that was a problem, and we had to re-enable later on vector clocks. And first we started with a big plan, and we wanted to have a multi-data center replication. And multi-data center replication can really go nuts. Especially in React, you have 2 ways of doing it. One is it's going to do it every chunk of time. By default, it's every 3 hours, I think. And one is the continuous replication. So both of them will introduce latency at some stages. And what we have in SMS Gateway is quite specific, because we get a lot of messages, and their like estimated time to live inside of the gateway usually is like very, very short. But that said, without React, we would not be able to deliver this product. React is really amazing, but you have to be aware that there are some problems. So, well, how do you tackle the problems? Initially, you think, okay, so we have a timeout, so what are we going to do? But in React, well, the backend for the React that we used was called Bitcast, and Bitcast is simply writing to a file, line by line, and every now and then he's doing a merge. So what we thought, yeah, if you are using normal disks, if you're going to swap them to SSDs, the merge will be faster. Yeah, you have many files, the merge will be faster. And we used the NUMA, non-unified access memory. Well, it was like, it was cool because it felt that it solved the problem, but it really masked the problem. For some time, we had it running and nothing broke. But later on, when we got a bigger volume, the problem returned. So what we had to do is we had to drop our idea of round-robining the connections to React and having many queues to simply have a one queue and develop something which is called a throttled queue, which will simply throttle the amount of messages that's going to go through it. And that's really cool because that actually solved everything. So another problem that we had was SMPP is the protocol that operators love, and well, it's not reliable. So sometimes you will have duplicates, sometimes you will have drops, and this is the edge case when you have to you have to draw a line and you have to decide what I'm going to do in edge cases. If I'm going to have duplicate messages or if I'm going to drop the messages. So what do you prefer, to be double build or triple build, or not being built? So this is open, like even today. So in edge cases where you're not going to get an ACK, but you actually, or you're going to get like some sort of like thing that looks an ACK, like an ACK, well, you have to like drop the message, and somebody will call the customer support, and they will be like, okay, cool, there was no payment, there was a problem. Yeah, the bigger problem is because the operators get angry when you double bill people. So we were at the point, at this stage, we were at the point that we still had React 0.12, and everything felt like, it's going great. So, so let's try some different stuff to solve the problems. Let's upgrade the React. And what happened? This happened. So we upgraded React from 0.12 to 1.2, and we started to see a strange behavior because you had like because the gateway works in a way that you have spikes of traffic. Yeah, between 8 a.m. and 10 p.m. you're gonna have really big spikes of traffic, and then you're gonna have 4 or 6 hours of almost nothing happening. Well, at night we have only Australia working, but they're not generating like a lot of traffic. But in Europe, you have like amazing amount of traffic during the day. So what happens is Erlang has a scheduler, and I think this problem was not existing in the previous versions than the R15. But in R15, in React, he was like going. So basically, we had 12 cores for every machine. So he was like maintaining 12 threads in Beam. And then when at night the traffic was like shaping in a much smaller manner, it was not like vanishing, he was dropping to 1 thread. And when in the morning we had like another wave of really, really high traffic scenarios, he was not waking up properly. So we had some like thoughts about it, and we were like looking how we can fix it and what's happening, and that was really crazy. But we found out that there is a flag, and there's like somebody implemented this this fix, which is ZDNFGTSE, which is like never go to sleep. Then when everything was set up and everything was running, yeah, you were happy. And your gateway is running, you're adding features, integrating international operators, everything is super. You love this situation. But then after like 2 or 3 years, you actually are asked to go to a backup box and dig out something. And then you realize that you have a folder where you were backing up all the logs, and you generate a billing log every second, and you do ls in this folder, and you just crash the box. Yeah, so that's the things that you're going to have regarding the maintenance of your applications. This is actually the last part of the talk that I want to give, but in my opinion, it's the most important things that you should have in life, where in your application, because we would be able to skip a lot of problems, like not knowing the size of the queues like properly, and knowing that having like many queues is not really the best idea for the same thing. If we would have like proper logs. So initially, if you're gonna look at the like Rails logs where we were used to it, if you're looking at Rails logs as a Rails developer, you see this, yeah. And when you're a developer, it's quite nice because you have like different lines, everything is there. But if you're having like 6-7 gigs of logs a day, looking at this for every request, grabbing this, it's not really possible. So what was done in Buzzard was that every single event in log is logged as a line. Yeah, so you have a timestamp, you have a type of the event, and then you have the params. And this enabled us to use different tools to aggregate the logs. Yeah. So we had this like great experiment, because if you have logs in your application, you want to have like them in one place, yeah? Let's say you have like 11 boxes, and you want to have all the operator logs from all the boxes, all the router logs, or the counter nodes, everything in one box, so you can like just search it, and it's searchable. So what we did, we installed the log stash on every box, and then we started to accumulate them and generate log stash is basically generating indexes for them. So after one day, we had 12 gigabytes of indexes for our logs. That was roughly the number of the logs that we had. It was not really the best. And the log stash was eating all the CPUs on every box. It was not the best if you're trying to keep up with the load on your gateway. But it has like a nice tool that you can use, which is called Qabbani, and see the stuff. Well, it's going to kill your gateway, but the logs will look pretty amazing. So we had to have it. We had to have something that will enable us to see the traffic, to see how it's shaped. So what we did is we used Hekadi or Heka and Graphite, and that actually worked amazing for us. So basically, Heka is like is a daemon which is written in Go, and when we deployed this to watch and parse the logs and send them to Graphite, that was like almost no footprint on the system. That was actually a really big surprise. And Graphite. So we deployed Graphite because we thought, okay, let's try it out. And previously, before we did it, we went to a meeting in London where the guy was talking about like mega. That was I think Basha meeting, mega deployments of Graphite with the React backend, and we were like, okay, let's try it out in small scale first. So we deployed 2 instances of Graphite and started to stream all our logs parsed to Graphite. And that actually, one box was actually enough to do it. And then we started to generate statistics based on the traffic that we can see in Graphite. And in Graphite, you can see stuff like, you can say, okay, last 15 minutes, last hour. So what we started to do, we started to generate alarms based on this. We started to do statistics based on this, and that's actually also really important to have. So the conclusion from the talk is that Erlang is actually pretty amazing, and if you're building anything that is like requiring you to have like a big traffic, I think Erlang currently is probably the only solution to go. Well, if you want to have something that is out of the box, React is also amazing, but you always can face the problems that that you're not aware, like out of the box that it can have. And what we did at start, what was like a bad idea, is to keep React nodes and application nodes on the same physical box. That's not the best idea, because inside of the gateway we use Bitcask to store the data, some local data like local retry queues and stuff like this, and React is using Bitcask on the box. So when they both start to merge, you can have a lot of descriptors used and some problems. Thank you very much. Any questions?
You mentioned you did multi-data center replication. Did you use React Enterprise for that?
Yeah, so we had the support. We bought the support in Basho, and we were using Basho patches and React Enterprise.
And how was it? Any problems or?
Well, for us we had some problems with the initial implementation. So because the main cluster. So currently, how it is set up now is we have two React clusters, and we have the replication going on. But at start, the main cluster was having timeouts, so that was leading to replication being slow, and replication being slow was leading to latency, like in the main cluster. So we had to disable the replication and start, because we feared that it's going to be a problem, that it could cause a problem. Yeah. Well, initially we were trying to use different stuff to actually find out what is the problem. Yeah. The problem was that we had unbound concurrency, and you cannot, generate insane amount of processes in Erlang and just leave them to do stuff. You have to have some way of scheduling it and doing it on your own.
May you tell a few words about testing and quality assurance?
Basically, on the gateway side, we had a tester, and this which was like a physical person testing functionally if the gateway is okay. And we had the unit tests for the gateway written in eUnit for Erlang, and that was it. So basically, we had like a person that was checking the gateway like 24/7 at start.
So you didn't have any like stress testing or something? Did you, let's say that after the release, did you find out that it was not good enough or something?
So yeah, we did the performance testing. And the performance testing was done, but the performance testing behaved differently than production environment. So basically, you can say, okay, we do a performance testing, and we can eat 20 million messages per second, yeah, and that's fine, yeah. You go into production, you have 5 million messages per second for 8 hours, and then you're like, okay, something is going wrong, or you have like spiky traffic, yeah. So maybe our stress tests were not super perfect. But initially, we did not thought that this is a problem. And if I can speak like today I think the gateway is in a state that there are no performance problems. More problems that we have is that there is a complexity in terms of implementation of the rules behind what operators want from us. And this sometimes implies that you need to have some extra data in the places that you don't want to do, and you can have messages that goes around the system and are in a really bad state. Well, we had this issue where one of the operators had a client with a broken handset, like physically broken handset. So some of our clients was trying to send. It was different. So it was broken. It was a physically broken handset, but he was trying to send an MO from it, and this operator was trying to retry this MO to sending the same MO, the same mobile originated message to the gateway every second, even if we act that we got it. So he was trying to repeat the process all the time. So that was putting the stress on the gateway. Well, not a lot, but that was a problem that you cannot really find if you have even if you have a tester, yeah. And this kind of problems happens all the time. Recently, we had a situation with an MT where the client was trying to send an MT, and that was to a ported number that ported many times, and none of the operators were actually saying that it's us, yeah? So MT was circling inside of the gateway because every operator that we support said it's not us. And we support all the operators in UK, and that was sent to a UK number.
Once again, thank you very much.